Hello everyone, so welcome back to my channel. Today we will solve n queens problem, which is a LEETCODE number 51, and yeah, it's a basically hard problem. So the question states that the n queens puzzle is a problem of placing n queens on a n cross n chessboard such that no two queens attack each other. Okay, and given an integer n written order distinct to the n queen puzzle, you may return as in order. Okay, so the question states that that we have to place n queens. Okay, we can take this example here. N is 4. Okay, so initially the chessboard okay would be empty. 1 2. Okay, so yeah, as you can see, there are 4 cross 4 16 boxes. Initially everything is empty boxes would be stated by dot. Okay, and let's say if you are placing queen here, then you will place q here. Okay, as you can see, for n equal to 4 we have output in vector of array of string, which is kind of vector of vector string only. Okay, so vector of string. Okay, in this format our answer will be. Okay, so what question says, question states that we have to place n queens such that no two queens attack each other. Okay, it's simple condition, no two queens attack each other, and there can be more than one possible answer, so we have to store every answer. Okay, so first rule of queen, let's say, what is the rule where q attack another q? Okay, so let's say if you are placing q here, okay, so q can move diagonally, q can move horizontally right or left. Okay, vertically up or vertically down it can move. It can move diagonally up, it can move diagonally upright, it can move diagonally right down. Okay, and it can move, so q can move possibly in 8 direction. Okay, so if any other queen comes in direction of this, then yeah, this queen will attack each other. Okay, so this is the rule. Okay, where one queen attack another queen. Okay, so let's say if n equal to 1, okay, sorry, if n equal to 1, then yeah, then there would be only one box. Okay, and wait a minute. Yeah, if n equal to 1, then there would be only one box, and we can place only n queens. Okay, so one more thing I need to discuss. As you can see, we have to place n queens. Okay, and our chessboard is of n cross n size. Yeah, n cross n size. So our chessboard is of n cross n size, and we have to place n queens. Okay, and we have condition that two no queens should attack each other, and we know that queen can attack horizontally right or left. Okay, so it means we have to place, okay, we have to place one queen per row. Okay, this thing we can reduce. Okay, how we can reduce? That we have to place n queens. The chessboard is of n cross n size, it means it have n rows, and as if two queens placed in a same row can attack each other, so we need to place one queen in one row only. Okay, this is a reduce. Okay, okay, so if n equal to 1 and we have to place one cube, then of course there is only one possibility. Okay, let's say if n equal to 2. Yeah, so what will happen in n equal to 2? Initially all chessboard would be blank. Okay, if I placed q here, okay, so what will happen? First I will place q here, okay, in the first blank. Okay, then for the second row where I would place, can I place it here? Can I place it here? No. Okay, of course I cannot place it here, it will attack. I cannot place it here, it will attack. So this is a wrong. Let's say I place this here. Okay, so can I place it here? No. Can I place it here? No. Oh, so for n equal to 2, no possible answer. Okay, let's say for n equal to 3. Just see what we are doing here. Okay, yeah, initially all would be blank. First I will place q here. Okay, then I can think of the second row. Yeah, I can place it here. Can I place third queen here? No. Can I place third queen here? No. Can I place third queen here? No. So of course this is the wrong answer. Okay, I will place q here. Can I place it here? No. Can I place it here? Can I place it here? No. So of course it will be wrong. Okay, first time. Okay, what I'm doing greedy here. Okay, I this was greedy, this wasn't greedy. Okay, so this was not greedy, this was greedy. Okay, so I will explain in more detail. Okay, but like see what I'm doing. I have placed the queen in first available option, and I have moved to second row. I have placed in the available option, queen in the available option, then I have moved to second row. Can I, then I'm checking, can I place q here in the third row? I cannot place. I cannot place, so I didn't get any answer, so I will backtrack. Okay, so yeah, so yeah, this is the wrong answer. What I then I have backtracked. Okay, then I have backtracked here. Okay, then I have moved this q position to further over. I have placed q here now. Can I place q in the second row now? No, I cannot place q in the second row. So of course I will backtrack. Then I will move this q to here. Now I will place q here. Then can I place q here? Of course I can place q here. Okay, now I will move to third row. Can I place here? Can I place here? No, I cannot place here. Can I place here? No, of course. Then I will do that. Yes, for n equal to 3 also we don't have answer. Okay, let's move it. Yeah, so for n equal to 4 also we can do this likewise, and yeah, what we will get, we can directly come to the answer, otherwise we will be stuck in example only. Okay, can see here only. One example is this. Here. So first we have tried on this basic queue here, okay. Then we have moved, then we have got that there is no answer, then we have backtracked, moved this queue to this position, then we have tried to place queue here, this is not valid answer, this is not valid, then we have placed queue here, okay. Then we have moved to this row, third row, okay. Then we have placed queue here, okay. After that we have moved to fourth row, we have found a possible answer, okay. So like this we have moved and we have got two answers, okay, in n equal to 4. So this is like examples, okay. One queue here, one queue here, one queue here, one queue here, okay. Yeah, so this is the one possible answer for n equal to 4. Now let's check what is the approach here. Think of a greedy. Will greedy work in this case, okay, for n equal to 4? Let's check this, because as you can see for n equal to 1, okay, what would be the greedy solution? Greedy solution is that place the queue, we can place one queue per row, place the queue in available option, okay, per row, and move forward, okay. So as you can see, this worked here also. N equal to 1 we have placed queue here, okay, this worked. For n equal to 2 we have placed queue here, we cannot place queue here, we have placed queue here, we cannot place no possible answer. Greedy worked, okay. For n equal to 3 also we have placed queue here, we have placed in the first evaluation queue here, now we cannot place queue, okay, so it failed. So yeah, greedy here worked here also. But for n equal to 4, let's see, okay. Place the queen in first available option, okay. The first available option for q is here, okay, done. Now we will place q here, okay, done. Now we don't get any answer for row equal to 2, okay, 0 1 2, okay. So when we are doing greedy, okay, it failed in n equal to 4, you can see, okay. We have placed first queue in the first column, we have placed the second queue in the second row and the third column. Now we are not having any possible answer, okay, according to greedy. But when we have done backtracking, then we know, yeah, there is an answer, okay. So greedy fails. And why greedy fails? Because the current solution, current choice is making failure in future cases. That's why greedy fails here, okay. Now we have deduced that greedy won't work, okay. So what's the intuition for backtracking? Okay, so greedy doesn't work, it is enough intuition for backtracking or recursion, okay. But still, okay, now your greedy fails, then what you will do? Okay, so as you can see, okay, your current choice is if you are choosing queue, if you're choosing to place queue anywhere in the current scenario, okay, it will affect your future case also, if it will affect your future failures also. Then why not to try a choice, okay, just try your choice, okay. If it fails, then just go back to your choice and change your choice, okay. So that's how backtracking works, okay. So, and why recursion? Okay, so yeah, you are trying a choice, okay. If it works, then fine. If it doesn't work, then backtrack to your request, okay. So basically it is kind of a promise, okay. At each row you are making a promise, okay, that current queen that you are placing current queen here, let's say, it won't attack pi from any previous queen. Okay, you are making this promise, and if it promise fails somewhere, like in this case, if it fails, then backtrack to your current scenario and change your promise. Okay, and make a new promise. Okay, so that's why it is a like intuition for a backtracking. You can see. So what you will do, okay, at each row, what you will do, you will try to place q. Okay, you will make a promise. You will promise. What would be the promise? Promise is that current placed q won't be attacked from previous placed q, and if it fails, what you will do, just backtrack. Okay, so yeah, this is intuition. So now we will, okay, now we will, what we will do, we will think of a base case. What's the base case here? Okay, so you can see, okay, what we are trying, what our function looks like. Okay, so what we are doing, what we are trying, we have a board. Okay, we have an imaginary board, we are placing q there. Okay, we have current I. Okay, what is I? I'm trying to place q at the ith row. Okay, so my promise is also like looks like that only, that I'm trying to place q at ith row such that it won't get attacked from the previous placed q. Okay, so we have our I, we have a board. Okay, and we have a current solution. Okay, let's say I have filled till here, I fill till second row, then I have this somewhere stored in my data set. Okay, how I will store, I will discuss later, but yeah, somewhere I need to store this, the current solution. Okay, so that is the base case. So sorry, that is the like current scenario. And what would be our base case? If I have successfully filled till I here, till I reaches here. Okay, I equal to 4. Let's say I have placed q at 0, I have placed q at 1, I have placed q at 2, I have placed q at 3, and I reached I equal to 4. Then it means I have successfully placed all 4 queens at the board. Okay, then that is my answer. Yeah, so that is a base case also. If I equal to n is a like number of queens, then let's say our answer, which was a vector of vector string. Okay, I will push back my temporary answer. Temporary would be like the answer stored till I. Okay, and I will return. Okay, yeah, so this is my base case. Okay, base case is done. Okay, what should I do? Okay, now let's try run. Okay, we will do some decision tree. We can check this. Let's say our n equal to 4. Okay, we have a function. Okay, help. Okay, what it contains, it contained I. Okay, it contained n, it contained temp is a temporary answer, n is a like number of queens or row, I is the current index where I am standing. Okay, now we will try to implement this function. Okay, and after that we will try to make decision tree, because after this function only we can visualize decision tree. Okay, so before that, what is our main function? Our main function looks like this. Okay, we have vector. Okay, what is the main function? I need to check then. this is solve n queens. Okay, solve n queens. Okay, here we have n. Okay, this is a function which we need to implement. Okay, okay, so this is our temporary answer. Okay, how it will look I will tell you, but yeah, we can declare one temp which is currently empty. Okay, and we will implement one function help, which I have talked earlier. Okay, we have imaginary board, we don't need to like keep the board and place and tune, because our temp will store our current answer. Okay, and we know the failure cases. Okay, okay, so yeah, help, and what we need to have, we have n, we are starting from 0, we have temp. Okay, and here we have vector of a string answer. Okay, we will return this answer here. Okay, so yeah, this is a like template or prototype. Okay, just forget about this, we need to implement this function only. Okay, this function is like making a promise that you will fill all the 8 position, all the nth position, okay, with the n queens, and you will return the answer. Okay, now we will implement this help function. Okay, okay, so yeah, this is void, as you can change position of in. Okay, this is n int, this is int, this is a vector of string. Okay, let's implement it. So first we will write our base case. Okay, if I equal to then write the base case push answer. Okay, and return. Okay, forget about this. Now, okay, what we are trying to do. Okay, when we are at any ith, okay, you can see when we are at any ith, we are traversing through j equal to 0, j equal to 1, j equal to 2, and try to placing q in every column. Okay, what we are doing at any I, we are trying to place q at every column. Okay, and then if we are able to place the queen here, how we are able to place the queen, we will check. We need to have condition here. Okay, we will decide, but let's say that is a function which will return true or false. Okay, so I will traverse through all j, and if I found any position, then I will explore the path, then I will move our I. Okay, this is simple thing. Okay, so what I will do, I will have a loop j where I will travel j equal 0 to n. Okay, okay, now what I will try to do, okay, I will check if I can place, rule check, I will try to check place, I will try to check if I can place I comma j comma temp comma n. Okay, we will discuss this place function. Okay, if I am able to place this, okay, how can I will call this function, this will return me true or false. Okay, if my check is true, okay, okay, if my check is true, it means I can place my q here. Okay, then what I will do, okay, I will have a string, okay, which will represent that row. Okay, so what it will make, it will, I am explaining it here, it is basically dot 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 n times. Okay, this line. Okay, so if I can place my q here, then I will like create that row, and that at jth position I can place. Okay, so I at jth position I will place the q. Okay, then for this row, this string is my answer. Okay, then I will push, okay, this string in my answer, in temporary answer. Okay, I have pushed string in temporary answer. Okay, then what I will do, I will explore the other option. Sorry, I will explore the path. What was the path? I was at I8. Now I will move to I plus 1. Okay, so I plus 1 comma n comma temp. Okay, let's say if this path fail, then what I will do, I will backtrack. Backtracking required this pop function. If I have pushed my string as answer and this path fails, then I will backtrack. Okay, I will close my loop. I will close my loop. Okay, this check condition closes, and yeah. Okay, so this is the complete solution. Okay, now what we need to discuss, we need to discuss place function that can check, okay, whether this place is suitable for placing the queen or not. That we can discuss, but before that, if let's make sure that we have understood this. Okay, what we have done, we have implemented a help function which will place q at i8 position in the n cross chessboard. What we have temporary answer, which is a answer till this point. Okay, with the answer till this point, we have checked. First, we have explored all the columns. With the help of temporary, we have checked if we can place our queen at j position, at I comma j position or not. If we can place, then we have make a string and we have placed queen at the j column, and then we have pushed that answer. We have explored the I plus 1th position. Then if that part fails, then we have backtracked the request. Okay, okay, and if this part gets success, then it will be captured under base case. Okay, this thing we understand. Okay, now we will take this function, we will talk about place. Okay, so we have I int j, okay, vector of string temp and int n. Okay, before implementing this, let's say, okay, let's do some example practices. Okay, how we gonna implement it? Let's say we have n equal to 4. Okay, we have put q here, we have put q here, I equal to 0, I equal to 1, I equal to 2. Okay, now I want to check this at this position. Okay, so what my temporary will be, what my temp will be, temp will be okay, this would be my temp when I would be at I equal to 2. Okay, this would be my temp. Okay, we have temp, we have I equal to 2, where we are trying to place, we are trying to place at j equal to 0. Okay, let's say not j equal to 0, let's say we are trying to place at j equal to 1. Okay, we are trying to place at j equal to 1. Okay, and what is our n? N is 4. Okay, now we have this condition. Now we want to call this place, and we want to check whether we can place q here or not. Okay, so let's say if I want to place q here, okay, do I need to check this row? No, because we know I can place one q in one row. Okay, do I need to check in this column? Yeah, I need to check this in column. Do I need to check in this column also? No. Do I need to check in this diagonal? No. Do I need to check in this diagonal? No. Why we don't need to check in the below, and why we need to check in the above? Because we are making a promise that if I place the queen here, that it won't be get attacked from the previous placed queen. Similarly, when we will reach at I equal to 3 or on the below columns, then of course there, if we place queen there, then it won't get attacked from this placed queen, because we have made promise, and if it promise fail, then we will backtrack. Okay, so by keeping our promise, we can avoid future attacks. Okay, then we don't need to check in the future condition where it will get attacked. Okay, yeah, so I think I have made myself clear. Okay, so where we need to check, we need to check this column, we need to check this row, we need to, sorry, this upper upper right diagonal, upper left diagonal. We need to check these three scenario: first, second, and third. Okay, okay. So how I will check, we are at I at comma j. Okay, how I will check this column? What I will do, I will take some c equal to 0. Okay, my column is fixed. Okay, what would the column is j. Okay, first I will check at 0 comma j. Do we have q in here? No, we don't have q in here. Okay, then it's okay. Do we, then I will increase my c 1 comma j. Do we have q in here? No, we don't have q in here. Okay, then this condition also passes, this condition also passes. Okay, then it means column check is passed. Okay, so first we need to do column check. Okay, second what we need to do, we need to do upper left diagonal. Okay, so how we will check upper left diagonal? So let's say if you are at I comma j, and if we want to move to this column, okay, then how we will move? You will do I minus 1, sorry, comma j minus 1, I minus 1. Okay, I comma j, I minus 1, j minus 1. You will move to this column. Similarly, you will try to move in this diagonal by reducing minus 1, minus 1, minus 1, and you will check whether we have q here, whether we have q here, whether we have q here. Okay, then you will check correspondingly. Okay, so for this you can check, for like this you can check upper left diagonal. For upper right, what you will do, you will do I minus 1 and j would be increasing this time, so you will reduce I till it becomes 0, you will increase j till it becomes n, and at every step you will check whether we have q in here. Okay, we have q in here, then it fails here. Okay, and you will return false. If we don't have q in here, then we will check for this upper right diagonal also. Yeah, likewise we can, if our all condition passed, okay, then we will return true. If any of this condition fails, then we will return false. Yeah, fail, then we will return false. Same for here, same for, if every of condition pass, then we will return true. Okay, okay, so now we need to do code for this. Okay, first what we'll do, we will do column check. For column check, what we will do, for int, we have our column at j. Okay, so we will change only r equal to 0 to where we can move from r, we will check till I only. Okay, we do not need to consider future cases. We'll do r plus plus. Okay, then if temp, okay, temp of r j equal to q, return false. Okay, column check completed. Okay, then upper left diagonal, what we will do, we will do, this time our r is I minus 1. our C means column is j minus 1. Where we will move till r equal to greater than 0 and c is greater than 0. What we will do, we will decrease this every time. Okay, if temp of r c q, then return false. Okay, let's okay. So now we will check upper right diagonal. For int r equal to, this time r will reduce and column will increase. Okay, till where? Till r is greater than 0 and till c is less than n, and we will do r minus minus c plus plus. Okay, if temp of rc equal to q, return false. If everything is okay, then return true. Okay, so yeah, this function here, it is pool place function. Okay, so let's discuss about time complexity and space complexity. Okay, TC. Okay, as you can see, for n equal to 4 or for any n, okay, you are placing a queuing in at every row. Okay, so let's say if you have placed q at first row, then for the second row you have n minus 1 choices. For first row you have n choices, for second row you have n minus 1 choices, for third row you have n minus 2 choices. Okay, so it's something like this. So you can see this is order of n factorial. Okay, one thing is this, and for this place operation, you for every I you are checking this place, okay, and times. Okay, and so this is and like if you calculate this is like you are checking at 3 index till I. So on an average it is order of n for every choices you made. Okay, so it kind of, it would be your TC. For space complexity, one is you are restoring this answer, okay, this board n cross n. Okay, second is your recursion space. Okay, so yeah, so yeah, I think we have discussed everything from till placing and kin. One thing I think we have, okay, for the decision tree, I think this would be a long video. For n equal to 4, let's say yeah, I will make decision tree here. So recursion tree or decision tree, whatever you say. Let's say we have n equal to 4. Okay, so we have started from I equal to 0. From I equal to 0 we will, this is our j. Okay, j equal to 0, j equal to 1, sorry, column 0, j equal to 0, j equal to 1, j equal to 2, then j equal to 3. Okay, at I equal to 0 you will call place, you can place this. Okay, Now you will store that string into temp. What, so here your temp would be, okay, this, okay, this is your temp, this is your j, this is your I. Now you have checked that you can place, yeah, you will place it, then you will move again to I equal to 2, okay, sorry, I equal to 1, okay. For I equal to 1, what you will do, you will again explore all the j, column 0, column 1, column 2, column 3, okay. So you will check, you cannot place here, you will check place, you will cannot place here. At j equal to 2, here you can place, okay. So you have placed for I equal to 0 0, okay, this is your temp. Now you can place it here, okay. You will check through place, okay. Then your temp would be, okay, this at 1 at 0 position you have placed q here, here you will place at second position, okay. This is your temp now, okay. Now we will explore again, you will explore this part. I equal to 3, again you have 4 options, column 0, column 1, column 2, column 3. Why I'm showing this decision tree? Just for backtracking, where you are backtracking, okay. You cannot place 0 here, you cannot place q here, you cannot place q here, you cannot place a q here. Now you will backtrack. When you will backtrack, you will pop this out. Now you will move to this column 3. Your answer would be temp equal to, again this. Now you will proceed with this column 3, okay. You will check, you can place at it here. Now you will push into temp, then your temp would be, your temp would be this, okay. Now you will explore this path. Now your I would be 3, okay. Your I would be 3. You will go to all path again, column 0, column 1, column 2, column 3, okay. You will check, then you can place at 0, yeah, you can place at 0. Then again you will go to I equal to 4, again you will explore column 0, column 1, column 2, column 3. You can place it here, okay. Then you will get I equal to, sorry, I equal to 3 here, 2 here, okay. I equal to 4, then you will push your answer here, okay. Answer dot push back temp here, okay. Whatever I was trying to show you, when you were at I equal to 3, you didn't get any answer, then you have backtracked and you have popped this out, okay. Then your temp would be this, and you have pushed another answer to temp, which was this, okay. So yeah, here you have done the backtracking. I wanted to show you this, okay. Rest of, so yeah, this is kind of a like recursion tree. My screen is lagging a little bit, but yeah. So yeah, this is a like last problem of recursion backtracking series. I will come with another series if possible. I will start, yeah, discussed TCNSC, we have discussed backtracking, intuition, we have discussed code, we have discussed samples also. So this was a long video. Okay, so let's meet you in the next series. Bye bye. Good night.